Example number 2. The personnel manager for Canadian Tire considers 5 criteria when interviewing a job applicant. She scores each category between 1 and 5, with 5 as a high score. Each category has a weighting between 1 and 3. Calculation. Determine the weighted mean score for this job applicant. So when you're doing the weighted mean score, you need to know the value of the applicant score, each of these individual values, multiplied by your weight factor. So I'm going to take each of these rows and multiply the numbers that you see in these rows. So the weighted mean and using the formula that I showed you in the last video, this is going to be x bar with the subscript w for weighted. And this is equal to the sum of all the weights times the x values divided by the sum of all the weights. So what does this look like? Well, this looks like there's 5 of them, right? So the weight 1 times x1 plus weight 2 x2 plus all the way to whatever weight value, how many n values in your data set times the nth value of your data set, and then the addition of all the weights on the bottom. Okay, so in this particular example, we have 5 numbers we need to multiply here. So it's going to be 4 times 2 plus 2 times 2 plus 5 times 3 plus 5 times 3 again plus 4 times 1. And all the weights added up, 2 plus 2 plus 3 plus 3 plus 1. You can kind of think of this as like, well, the weight factor is telling you how many times am I considering this education score. So I'm going to consider the education scores, twice, so 4 and 4, then 2 and 2, and then 5, 5, 5, 5, 5, 5 again, and then 1, 4. So basically, I'm saying the weight factors is basically either doubling or tripling the number that I have here. Which is why when we divide, instead of dividing by the number of numbers, I'm dividing by the number of weights, because it's like I'm saying, well, 2 plus 2 plus 3 plus 3 plus 1, which is 11. It's like I'm saying that I'm taking the mean of 11 numbers. It just so happens that some of these numbers are repeating, right? So what turns out to be starting off with 5 numbers is 11 numbers. You can think of it that way. Otherwise, just apply the formula, and you won't go wrong. Okay, so if I multiply and add all these numbers in the top, I'll have 45, and on the bottom I have 11, and when I divide those two numbers, I get an average of 4.2. That's my score, average score. So calculation: how does the weighted mean differ from the unweighted mean? So if you didn't put any weights in your mean, then your mean value would look like this. It's the sum of all the scores divided by the number of scores. So my scores are 4 plus 2 plus 5 plus 5 plus 4 divided by 5 scores that we have, and my mean would be 4. So the weighted mean would be higher than the unweighted mean, which is more advantageous to the applicant. So I'll just say here the weighted mean is higher. Well, higher than your unweighted mean. All right, and then here, part C, what do the weighted factors indicate about the company's hiring priorities? So if you look at the weighted factor, it says here that the company is placing more importance on interpersonal skills and communication skills, and there's less importance on references here. Okay, so let's go down to example number 3. A group of children were asked how many hours a day do they spend watching television. So here's an example of ranges, things that are happening in ranges, and we have a frequency for each range. So we're going to calculate here the mean, okay, the mean using midpoints and frequencies. So the midpoint, the halfway point between 0 and 1 is going to be 0.5. The halfway point between 1 and 2 is 1.5. 2 and 3 is 2.5, and I think you can see the pattern that it's going to be 3.5, 4.5, and 5.5. These are the midpoints, the halfway points within each interval. Now, the next column is the frequency values, so how many times each interval is occurring. So we have 1 of for the 0 to 1, 4, then 7, then 3, then 2, then 1. Remember, these are values of hours watching TV. So there's one child who spends for less than 1 hour, 4 children between 1 and 2 hours, 7 children between 2 and 3, and then 3 children between 3 and 4, 2 for 4 and 5, and 1 child for 5 to 6 hours of TV. Altogether, when you add these up, the sum of all the frequencies is 18. So we had 18 children. It looks like it might have been surveyed. Yeah, they were surveyed. So there are 18 children who were surveyed. And what I'm going to do next is now look at the cumulative frequency here. So this might be another useful value for us. So we have one person here. For the next row, we have we're going to just keep adding the frequencies together. So 4 plus 1 is 5. 5 plus the next number here is 7, which is 12. Bring down the 12. 12 plus 3 is 15. And bring down the 15, add the 2, we get 17. And then we bring down the 17, we add 1. We get the 18 children who were surveyed. Okay. Now, for the calculation of the mean, I do need the frequency multiplied by the midpoint. So I'm going to take my midpoint here, 0.5, multiplied by 1, and I'll get 0.5. I'm going to take my 1.5 multiplied by 4, and I'll get 6. Take the 2.5 multiplied by 7, and I'll have 17.5. And I think you see the idea here. The answers for the rest are 10.5, 9, and 5.5. Now, if I sum up all these numbers, at the bottom here, I'll have 49. Okay, so my mean is going to be x bar equals the sum of all the frequency values times the midpoint values divided by the sum of all the frequency values. Okay, and the sum of all these midpoint frequency values is 49 divided by the sum of all the frequencies, which is 18. So my mean value is 2.7. So the average amount of time students spend is 2.7. 2.7 hours. So that's my mean. What about the median? So the median, let's write this down here, the median. So we have 18 values, so 18 children. So what we're going to look at is the 9th and 10th value. Okay, and so where does the 9th and 10th value occur? So they occur, so the 5th value goes up to the 1 to 2 hour slot. So the 9th and 10th value are going to occur in the 2 to 3 hour slot, the third interval. Okay, so I'm going to write here both values occur in the third interval. So our median equals the midpoint of the third interval. Remember, we don't have specific values here, right? We don't know between how much, if it's 2.1 hours, 2.9 hours. It was never asked. They were only asking them in what interval. So for this to work, it makes the most sense to just use midpoints of our interval. So the midpoint of this is 2.5. 2.5 hours. What about the mode? When we talk about the mode, we're looking at the modal interval. Which interval had the highest frequency? So look for the interval with the highest frequency. If we look back at our table, you'll notice the interval with the highest frequency is that 2 to 3 hour interval, because it has 7 children who said that they watched 2 to 3 hours of television. So this is going to be the 2, 3 interval, 2 to 3 interval, 2 to 3 hours. And if you figure out y is one square bracket, one is y one rounded bracket, square bracket includes the 2 hour marks. If they watch exactly 2 hours, that would be included. The round bracket indicates that we're not including 3, but every number before 3, so 2.99 would count. Okay. So the last bit here, analysis. Why are these values simply approximations? Well, there's approximations because we don't know specifically where within the interval we find a data point, right? We don't know what the child said specifically. They just put them in the interval. So we just have to assume the use of the midpoint. Okay, and that is my last example for this lesson. So we had one example where we had midpoints and frequencies, calculating their averages. My second example from here was using weights and values to calculate your averages. And the example from the previous video was a mean value calculation, just using values and the number of values. That ends the lesson.